Good morning, students. So we'll move on to the next topic, that is handling multiple devices. So this topic is under the concept of interrupt. Okay. So what is interrupt? From previous class, we discussed regarding the interrupt. Interrupt means a hardware signal which is raised by the devices, those who are expecting the services from the processor exactly. Okay. So what are the different lines you are getting involved for this generation of interrupt request and transmission of interrupt request signal towards the processor? Yesterday we discussed like interrupt request line, interrupt acknowledgement line, then interrupt service routine, something we discussed, then interrupt latency. So these are all what some important topics under interrupt exactly. Later, we discussed regarding interrupt hardware. Fine, interrupt hardware. So like open drain or open collector is the structure we are using for generating the like interrupt signal using the hardware exactly. So VDD will be equal to 1 always. Okay, so if any device want to raise an interrupt request, then we need to close that open drain latch. Then the voltage will be grounded to 0 exactly. Okay, then we have a NOT gate in the end of the interrupt line inside the processor. So when we are having 0, the complement of that we are receiving it as 1, okay, which will indicate the processor that someone is raising the interrupt request. Clear? Okay. Then later, we are having a problem of like processor to get enter into a infinite loop. Okay, infinite loop of what? Like providing a service for the same request. Okay, like whenever the device is raising an interrupt request, it will wait for few duration. Okay, if that waiting time elapses, okay, then it will start generating the interrupt request for the same task exactly. Okay, so to avoid that, what we need to do, we need to have an option of enabling and disabling of interrupt request for a device exactly. These are the topics which we discussed under interrupt in the previous section. Okay, so now we got lot many doubts. Okay, while discussing the interrupt topic, like we are having a common line. Remember, okay, we don't have an individual line. Like in a normal system, we don't have an individual line for raising an interrupt request, and we will be having a common interrupt acknowledgement exactly. Fine. Okay. So now there are total 4 questions. Okay, we need to discuss. Fine. How can the processor recognize the device requesting an interrupt? Okay, yes, it's a very important question. Like how your processor will identify, yes, this is what the device who is raising an interrupt. Okay, because we are using a common line as I mentioned. Okay, so one common line will be there for that each and every devices are getting connected. Okay, so we are having open drain collector, right? If you are closing the latch, then the voltage will drop to 0. Complement of that, your processor will get notification regarding the interrupt exactly. But how to identify? Yes, this is what the particular device who is raising an interrupt request. First question. Okay, for this, remember for this question, we have a subtopic called as vectored interrupt. Okay, vectored interrupt exactly. Okay, later. Second question. How can the processor obtain the starting address of the appropriate routine in each case? Okay, routine stands for what? Interrupt service routine. Interrupt service routine. Okay, so now it is not compulsory like always device should be raising an interrupt request for the same kind of problem or same kind of issues example. Okay, it may be raising a interrupt request for different reasons over there. Okay, so now the question is like how your processor will be able to identify that yes, this is what the starting line of that particular routine which should be executed by the processor and which is expected by the which is expected by the device exactly. Okay, second question. For this also, we are having a solution under vectored interrupt. Okay, what is vector? Okay, we will be having sign and magnitude, right? Okay, like that here also, we will be having a sign towards what? Yeah, sign towards the device address and also regarding the address of or else the beginning location of the service routine. Okay, we'll see this how we can trace the starting address of the service routine and the device address. Okay, when we are discussing under vectored interrupt. Okay, right. Later. Third question: should a device be allowed to interrupt the processor while serving another interrupt request? Okay, see your processor is right now. Okay, around like 9:58 it is morning. Okay, so 9:58 your processor is busy. Feel it, your processor is busy with providing a service for monitor. Okay, now we have a same kind of device I would like to take, like output unit or someone. So speakers we got, fine. It is a audio output device it is. So he is expecting some service exactly. Okay. So now the question is whether he is allowed to raise an interrupt request or whether he is allowed to disturb the processor when he is serving for another interrupt request from the monitor example. This is what the second question, third question. Yes, we can obviously. Okay. For this, we are using handling multiple devices. Handling multiple devices. Okay. The solution will be handling multiple device topic. Okay. There we are going to observe a special variety of hardware setup for only handling the interrupt. Remember, not for the other task, only for handling the interrupt, like simultaneous, sorry, multiple requests. Okay, if it is available for handling that, we are having handling multiple device request topic over there. Okay, there we will discuss about this question. Okay, fine. Then the fourth one, how should two or more simultaneous interrupt requests be handled? Right? Okay, like how to identify or how to deal with. Okay, like if you are having like multiple number of devices connected, okay, fine. So if they are like one after the other, if they are generating the interrupt request, then fine, we don't have any issue, right? Okay, but if they are generating the interrupt request simultaneously, fine, then how we can deal with that? Okay, for that also we are having a topic called as simultaneous interrupt request. Okay, so these are the four very important questions. Okay, so which can be solved or which can be overcome using the following three topics. Very important, students: vector interrupt, handling multiple devices, and simultaneous interrupt request. Fine. Okay, so we'll move on to the vector interrupt. We don't have any figure for vector interrupt, but we got for handling multiple device and simultaneous interrupt request. So, okay, fine. Vector interrupt: a device requesting an interrupt may identify itself directly to the processor, right? This is what the best solution, is it or not? See, like one system, okay, may be connected with many number of devices. Okay, let me name it like total 10 different devices, input, output, any other maybe. Okay, in case of memory also, okay, like primary memory, secondary memory, cache memory, registers, lot many things are available, right? Okay, so now, like if processors start searching for the identity of a particular device, then it will take a lot of time. Remember, I'm sure. Okay, and I'm sure that it will take a lot of time. So, what we can do is, whenever a device is requesting for any interrupt, okay, or if it is requesting for any kind of a service from the processor, if they introduce itself, okay, to the processor, then we can skip the finding the identity of the device by the processor, right? So same thing we are going to do over here. Okay, so vector interrupt states what the identity of the devices, those who are trying to get the service from the processor. Okay, then the processor can immediately start executing the corresponding interrupt service routine. Okay, if processor is able to identify the identity, okay, of a particular device, okay, then easily he can start behaving, right? Okay, he can start executing the service, whatever the device is expecting over there. Okay, so this is what the solution. A device requesting an interrupt can identify itself by sending a special code to the processor over the bus. Okay, so using that same interrupt request line along with the rising of interrupt signal, hardware signal, what we need to do, we need to add a small code, okay, so inside which we will be having the identity of that particular device, source device, remember. Okay, so whenever this interrupt request is received by the processor, fine, received by the processor, what will be the next step? It should give an acknowledgement to that particular device, is it right? Okay, otherwise we are raising one more interrupt request over there. That should not happen exactly, right? So what we need to do, we need to raise an acknowledgement towards the source device exactly. Okay, now the question is, like how the processor will particularly point out that acknowledgement towards the source itself, okay, because of this particular code. Okay, while sending the interrupt request, we are sending a small piece of code inside which the source address, along with that, okay, one more thing we need to add, okay, that we will see later. Okay, what we need to add, okay, the second parameter we need to add over here. Okay, but while sending a request, okay, in case of second point, okay, we are sending our device address to the processor, by which processor can easily identify who is that particular device who is raising this particular interrupt request exactly. Okay, fine. Later, third point. So this enables the processor to identify individual device even if they share a single interrupt request line. Obvious, we have only one request line, total 10 to 15 different devices are connected. Okay, so everyone will be sending the interrupt request using this particular line itself, but how processor will identify the device who is sending that particular request based on the code. Clear? Okay. This code supplied by the device may also represent, okay, this is not sure, but may also represent, okay, the starting address of the interrupt service routine for that device. Clear? Okay. One simple example, like in case of any input device, okay, obviously, the most of the time, the expected service by the device will be what? Read operation, right? So whatever the user inputs are available, that will be available in the data in register. So we are setting SN is equal to 1 so that processor can be intimated, okay, regarding the information. Okay, so in the response of that, what will be the action taken by the processor? Obviously, the read option, right? Okay, so read will be the procedure, okay, which should be executed by the processor exactly. Regularly, it will be performed. Okay, so now what we can do, we can just give the information to the processor that, okay, we need to perform a read operation over here. Okay, but it is not always, okay, because it is a job of a processor, but sometime, okay, like high-end devices, if they want, okay, they can transfer this piece of information over there. Okay, so two questions from the previous slide, like first one and second one, how to identify the device address, how the processor will come to know regarding the starting address of the service routine, okay, can be overcome using vectored interrupt. Clear? Okay, so now we'll go for handling multiple devices. Okay, interrupt nesting we are calling it. Okay, handling multiple devices. Like if you are having many number of devices connected and like more than one interrupt requests are available, okay, then how to deal with that? Okay, we have, okay. So here we got a topic called as interrupt nesting. Okay, what do you mean by nesting? Nested if we have, right? Okay, like if inside if condition. Okay, like nested if. Okay, inside one if, one more will be available. Okay, if any like one more condition if you want to declare, yes, one more if can be declared over there. So total three if statement, all are nested exactly. Okay, so like that, we are calling like nesting in case of if condition in C programming, right? Okay, so now interrupt nesting means what? The name only indicates like interrupt inside one more interrupt. Okay, means very simple. See, if your processor is busy with providing a service for one particular interrupt request, okay. So in between that service, if any other device is raising an interrupt request, if your processor pause the execution of the first interrupt request and if he start serving the second interrupt request, okay, which has arrived new, okay, then we are calling it as what? Interrupt nesting. After providing the service for the second, the processor will come back to the first one and he will finish the job. Clear? So this process we are calling it as interrupt nesting exactly. Okay, fine. So in this particular figure, just observe, we are having something processor. Okay, after that processor, we are having a like white column exactly. Okay, we are naming it as what? Priority arbitration circuit. Okay, priority arbitration circuit we have. Okay, like which will be working based on the priority of the devices exactly. Okay, so here is the section, the priority arbitration circuit. We will be having a chart, okay, of the priority of devices. Remember, we'll be having a chart of what? Priority of the devices. Okay, and see, device 1, device 2, device P are the like P number of devices which are connecting to the processor. Okay, and one setup we have, observe it carefully, one setup we are having, what is that? Instead of having a common interrupt request line and common interrupt acknowledgement line for all the devices, okay, we are providing a individual request line and individual acknowledgement line for the devices over here. Okay, see, you may ask like while we are discussing about the interrupt hardware, okay, we had only one line, yes, obvious, okay. So in the next slide, we are using like we are using one figure. There also we are having single line interrupt request line. Okay, but why it is for interrupt nesting? Remember, okay, if you want to go for a best performance by your system, Okay, then what we need to do? We need to purchase a high-end system, right? High-end systems are costlier. Is it right? Okay, like basic version, you may get a laptop around like 30, 32,000 and all. Okay, the high-end laptop, okay, it may cost more than lakh. Is it? Okay, for what purpose they are charging such a huge amount over there? For what purpose? Okay, see, if you are expecting a best service, then something should be available, okay, reserved for a particular task. Okay, if you are making that reservation for a particular task, then obviously the hardware components which you are using will be more, right? Okay, then it will be charging more. Because of that, you will be having high cost for high-end system and low cost for low-end system. Okay, so now if you are expecting, remember, if you are expecting a high kind of performance from your laptop or from your system, then better to go for this kind of interrupt nesting circuit. Okay, so which will help us to complete the interrupt kind of task faster. Yeah, okay, so in next slide we will come to know like what is the working of this particular device, particular figure exactly. Okay, so now I would like to explain this particular figure. So here we got a processor and priority arbitration circuit we are having. So those who are connected to the processor, okay, using these particular lines, okay, so individually they will be having the priority level. Okay, what is this priority? Okay, see, consider like device 1 is having priority number 3, device 2 is having priority number 1, and device P is having priority number 2 exactly. So now we are discussing about what interrupt nesting exactly. Okay, so now observe it carefully. If device 1 want to raise an interrupt request, want to raise an interrupt request, then how it will be rising? Yes, he will just close the open drain latch. Because of that, obviously we will be raising an interrupt request INTR1. So that will be going for the processor. So here, instead of directly sending it for the processor, we are just like checking that what is the priority level of this particular device. What is the priority level of this particular device? 3 exactly. See, those devices, those who are connected to our system, okay, everyone will be having its own priority level. Remember, yeah, okay. So when we are considering like priority in case of the office, okay, like managing director will be highest priority, like then manager, okay, like MD will be having highest priority, then office manager, okay, then office superintendent, then first division assistant, second division assistant, then group D, like attenders and all. So these are the what designation, okay, according to designation, they will be having their own priorities. Okay, if MD says something, that will be followed by everyone. Same thing if attender says, then whether MD will be listening over there? No. Okay, so this is what we are calling it as what? Priority. Clear? Okay, each and every person will be having their own priority or own level, okay, in case of the office. Okay, likewise here also, okay, your processor will be deciding the priority level for the devices over there. For input device, one kind of priority; for output device, one kind of priority; for memory, two different kinds of priorities are available. Primary memory, highest priority; secondary memory, next priority over there. Right? Okay, like this, we are having different devices, and each and every devices will be having their own priority level. Okay, so now you can observe we have a setup like individual interrupt request line we are providing, and interrupt like individual acknowledgement line we are providing. For what reason? For what reason? I tell you for what reason it is. Okay, but not now. After 2 minutes, I will be explaining that. Okay, so now device 1 is raising an interrupt request, so that will be received by the processor. So first it should enter to the processor arbitration, sorry, priority arbitration circuit. So here we are just naming it as what 3 exactly. Okay, your processor will be noting the priority level of that particular device over here. Okay, fine. So this is what the chart. Now processor will be keep on providing a service for this particular device. Okay, so along with that, after receiving the request, so using this particular line, okay, processor will send an acknowledgement to this device and he will start executing the service. Okay, fine. So meanwhile, if let me select the device P exactly. So device P, who is having a priority level 2, want to raise an interrupt request, then that will be raised using this particular line. So that will be received by the processor exactly. Now, we need to check what is the priority level of this particular device. What is the priority 2 exactly? Your processor is busy with this, with such an interrupt request, who is having a priority level 3 exactly. Okay, comparatively, 2 will win exactly. Okay, compared to these two priority levels, 2 is higher, 3 is least. Okay, so what processor will do is he will just pause the execution of this particular interrupt request by device 1, who is having priority level 3, and he will start providing a service for 2 exactly. Means device number P. Okay, This process we are calling it as nesting. Okay, this process we are calling it as nesting exactly. Fine. So now you may ask like, why we need to go for individual lines over here? Okay, why can't we go for a common line? Okay, see, if you are, wait a second. So let me go for the next figure. There I will show you. Like if you are not using individual line, if you are using a common line, then how you are connecting the device, only that you need to observe. Okay, don't worry about the topic and all. Okay, so just observe. So this is what the gesture. Okay, if you are having only one interrupt request line and one common interrupt request line and common acknowledgement line. Clear? Okay, fine. So here we are facing one problem. Okay, what problem? I will explain during simultaneous request exactly. Okay, then you will be having a clear picture over it. Okay, if you are having individual line, so no need to wait for this particular interrupt request line to get free over there. Remember, okay, and no need to wait for any other device to release the acknowledgement like which is received by the processor exactly. See, in this figure, okay, fine. If you are raising an interrupt request, easily you can raise, no issue. Okay, here we don't have any devices. We are just connecting the devices to this particular line, right? But in case of acknowledgement, see, just observe this structure we are calling it dicey chain. Okay, dicey chain structure it is. Acknowledgement will be traveling through the devices exactly. Okay, if this device one want to block the acknowledgement, yes, he can. Okay, otherwise he will let the acknowledgement to pass. Here also device 2, if you want, he can block that acknowledgement over there. Okay, then the last device should be waiting for all the devices to release the acknowledgement over there. Okay, so if that happen over here, then the performance of the system, what you are expecting, we cannot achieve. Okay, like reserved kind of resources should be available, then only it is possible. Yeah, assume it like you are in a big seminar hall, okay, which is having a capacity of 1,000 students at a time. Okay, like if all the students are having a personal mic, okay, and if anyone want to speak, then from his seat itself, whenever he wants, he can use that mic, right? His voice will be audible for all the students. Okay, but just assume for 1,000 students, if I provide only one mic, then how it will be, right? Okay, that person should wait so that that might get free over, right? He need to wait for his chance. But here in this interrupt nesting figure, okay, no need to wait for someone. Okay, if you are available with interrupt request, just directly send to the processor. You will get a individual acknowledgement from the processor exactly. Okay, see, only difference is what, don't worry about this individual line, and the only difference is what, we will be having a chart called as priority arbitration. Okay, so based on which we are going to analyze, okay, the interrupt request is raised by what kind of priority level device exactly. Okay, if it is okay, fine, like one more example I would like to take. See, here we are having a device, one is having priority level 1, 2 is having priority level 3, and 3 is having priority level 2. Consider like that. So now like device P want to raise an interrupt request, so it will be identifying itself to the processor that he is having a priority level 2 exactly. Meanwhile, device 3 want to raise an interrupt request. Okay, so now while providing a service for device of priority level 2, okay, whether it is allowed to suspend the execution of 2 and start the execution of 3, no, it is not possible. Okay, because when you are comparing, priority level of 2 is more compared to the priority level of 3 exactly, right? So your processor will first complete the execution of 2, later it will come for 3 exactly. Remember this. Okay, so this is for what exactly? For achieving the better performance. That's it, nothing else. Okay, so here we got some points over here. Processor will not respond for other interrupt requests while serving for one. Okay, which may lead to serious damage for system. Okay, like sometimes if your processor is busy with one particular device, okay, and like we are rising, your system is rising a interrupt request which is regarding the OS crash. Okay, immediately we need some service, right? Okay, but your processor is busy with the execution of a interrupt request from the input device. Feel it? Okay, then your operating system entirely it may get crashed over. So that should like that should not happen exactly. We should have a proper system, okay, which should work based on the priority level of the devices. Input device, output device. Okay, if you are providing service after a few seconds, also no problem. Okay, it won't harm your system. But few sections are there. Okay, like error. Okay, like in case of interrupt from the operating system, interrupt from the main memory, system failure and all. Okay, so we need immediate action over there. Okay, so we have to define the priority level for the individual section of our system. Okay, hardware section or any other components, whatever we are using. Okay, so according to that itself, we need to work. Yeah, I hope you got why we need to go for this interrupt nesting mode. So we need to have a system work based on priority of the device. Processor status register have a status chart using which interrupt nesting can be achieved. Okay, so example interrupt from device priority 3 while serving if interrupt from device priority 4, processor won't respond. Okay, because you are serving with 3, you are getting a request of the priority level 4. Okay, so processor will not suspend the execution of priority level 3 interrupt request. Okay, but if interrupt from priority 2 occurs, okay, processor pause the priority level 3 and it will start serving the priority level 2 example. Okay, later priority 2 will be finished, later it will finish the priority 3, later it will come for priority level 4 example. Yeah, okay. To implement this, we need a individual interrupt request line and individual acknowledgement line, so that no need to wait for request line to be free exactly. Okay, so this is regarding interrupt nesting exactly. Next, simultaneous request. Example, consider we are having like three devices in each priority level. Okay, so this is feel that this is what the image of the devices those who are connected to the processor all are having priority level 1. Okay, all are having priority level 1. Okay, then how to break the tie over here? Okay, so previously we used to break the tie based on the priority level, all are having priority level same. Okay, now you may say like we can break the tie using the arrival time of the interrupt request routine. See, feel that like 9 o'clock. Okay, first device is raising an interrupt request, then later 9:05 uh, third device is raising an interrupt request. Okay, later 9:10 second device will be like raising an interrupt request. Then easily we can provide the service. Like first arrival time of the first request is at 9, second will be at 9:05, and third will be of 9:10. Easily based on arrival time, we can easily provide a service for these devices exactly. Sorry. Okay, but feel that all are having the same priority. Okay, and all are raising the request at 9 o'clock. Then how to break the tie? Huh? How we can break this tie and how to select the individual interrupt requests so that we can provide a service for those particular devices. How to select? Any guess? See, this is what a arrangement we are calling it as what daisy chain. We are calling it as daisy chain. Okay. So now assume that all the devices are raising an interrupt request. Okay. So now processor is receiving a interrupt request from the devices exactly. All three are waiting exactly. Feel that all three are waiting. Okay. Simultaneously they raise the interrupt request. So processor feel that it is a single interrupt request. Remember this. If it is a simultaneous interrupt request, your processor feel that okay, it has only one interrupt request. So what processor will do is he will just generate only one acknowledgement. Okay, observe it. After generating the acknowledgement will travel from processor to the first device, right? Processor to first device, right? So now observe it carefully. If this device is waiting for the service from the processor, he will block this acknowledgement here itself. He will not let the acknowledgement to cross. Okay. So now after blocking, he will introduce himself to the processor by sending a address and also by sending a initial location of a service routine. Okay, then easily processor will provide the service for this particular device. Okay, so now what has happened? We are raising an interrupt request. So device 1 got the service. So the waiting time of 2 got expired. Okay, waiting time of 2 and waiting time of n got expired. Okay, they are feeling that they didn't receive the acknowledgement. Obviously, it has been blocked by the device 1. Because of that, they are not able to receive the acknowledgement. So what they will do? They will raise one more interrupt request. Okay, you may ask, so multiple number of interrupt requests we are facing. So processor may enter a infinite loop. No, because simultaneous it was, so it will be considered as a one request, right? So for that one request, processor has already provided a service over. So now Second time, device 2 and device 3 or device n, again they are raising an interrupt request. Now he is not raising an interrupt request. Why? Because he has already raised an interrupt request for this particular task and he got the service back. Yeah. So now device 2 and device n are raising an interrupt request using this particular line. Then same processor will feed that it is a single interrupt request line. Again, one acknowledgement will be raised or generated. So now the acknowledgement will come for device 1. Now he is not available with any kind of a pending request. So he will let the acknowledgement to pass through the device 1 example. Okay. After that, the acknowledgement will be received by the device 2. Again, he will block because he is waiting for the service. Same thing he need to perform, like he need to activate the vectored interrupt by introducing itself to the processor along with the starting address of the service routine. Okay. So now the expected service of device 2 is also over. Okay. So we are with only one request. So device n will rise and one more time, like waiting time of n will be expired. So he will rise and one more request. So that will be received by the processor. Okay. So now we are having only one. Okay. So these two devices will not rise an interrupt request for that particular job exactly. Then one acknowledgement will be raised. Okay. So now acknowledgement will be traveling for device 1. He will not block it. He will let it pass. Then device 2 will also let that acknowledgement to pass to the device n. Finally, that acknowledgement will be received by the device n. Again, he will introduce himself for the processor by sending a address of the device along with the starting address of routine exactly. Okay, so this is how simultaneous interrupt request can be sorted out. Okay, when we are using a common line for interrupt request line and a common acknowledgement line. Clear? Fine, understood. Any doubt? Very, very important, students. Okay, so this is what the drawback of dicey chain means. The devices who are connected close to the processor will be having more advantage. Remember, see, like whenever acknowledgement is generated, device 1 will be the common one, right? Okay, acknowledgement should pass through device 1 exactly. So whenever he is having service, he will just block it. So you will get the complete service from the processor when we are comparing with the device 1. Okay, he will also get the service, but comparatively, waiting time for device 1 will be less and waiting time for device 1 will be more because he is connected with far from the processor using bisection. Okay, okay, student. So this is what simultaneous interrupt request is. Now, the last topic, exceptions. Like what are the reason for raising an interrupt request that we will see. First one is recovery from the error. Okay, so whenever we face any kind of error in case of operating system, in case of your hardware, in case of bootstrap programs, like while loading the operating system, some files may be missing over there. Okay, or else while installing the operating system, some file, like we used to do the skip option, right? Okay, like you need to press always skip option, like we don't concentrate sometimes. Okay, so because of that, some files may not get installed to the operating system. Then like while operating, okay, after installing, okay, when we are using our laptop and all, then there will be some error message available in our screen. Okay, that is what the interrupt we are calling it as. Okay, like the operating system want to recover from the error. Because of that, he will be intimating the user that so these are the errors happening or these are the file missing number. Okay, so whenever we want to get recover from the error, there we can write an interrupt request. Remember one condition, like debugging breakpoints. Okay, the user programs, whatever we are having, right? Okay, so like we are going to set some breakpoints where the errors are available. Okay, every time, like everywhere, we need to raise an interrupt request. For what purpose we are doing this? So that it should not harm the internal files of the program or internal files of the system exactly. Sometimes it happens. See, next one, privilege instruction we are having or exception we are having. Okay, so this is what the reason, okay, why we need to go for generating a interrupt request based on the breakpoints. Like wherever we have an error in the user program or due to user, like what are the errors happening, okay, in our system. Okay, everything should be noted, and for that particular point, we need to start raising an interrupt request over there. Okay, otherwise, we are entering for a serious trouble. What is the trouble? Just observe. To protect the operating system of a computer from being corrupted by user program. Okay, maybe some software, maybe some virus. Okay, see, your system or your processor, okay, will be in two different modes. Okay, supervisor mode and working mode, two different will be there. Okay, whenever it will be in a supervisor mode, okay, it will be like the entire thing will be under the control of what operating system, obviously, okay, and the user, right? Remember, okay, so now due to the action or activity of a user, okay, we may be having some trouble in the operating system, or it may, like some files we are trying to install which may harm the system over here. Okay, so now so your processor is in what supervisor mode exactly. Okay, like supervisor mode to working mode, if you want to switch, okay, there will be a small time gap over there. Okay, so in that time gap, the user program may harm our operating system. So what we need to do whenever we find such kind of condition, okay, like when processor is in supervisor mode and there is a user file which is trying to harm the operating system, okay, before we switch, okay, we are going to execute some piece of code, okay, which will temporarily block that particular user program to harm the operating system. Okay, that we are calling it a privilege codes, okay, or privilege exception we are calling it. Okay, from the switch from supervisor mode to normal mode, okay, there is a small time gap. Okay, in that time gap we are executing some piece of instruction or piece of code that we are calling it a privilege. Okay, so these are the what the concept of interrupt exactly. Okay, very important topic, students. Okay, one fixed question. Okay, it may be 4 marks, it may be for 8 marks, doesn't matter. Okay, one fixed question from module number 2 is over interrupt. Okay, they may ask you to explain what is vector interrupt, then later interrupt nesting and simultaneous interrupt. They may ask exceptions also. They may ask what are the reasons for the generation of the interrupt. So these are the three very important three reasons. Okay, then later interrupt hardware also they can ask, and for 4 marks sometimes like what is interrupt, comma interrupt latency, interrupt request line, such kind of definition also they may ask. Okay, okay, students, so this is it for now. So from next video we will start about DMA, direct memory access. Okay, okay, students, thank you.